Graphing rational functions. So this is part 2. We're going to look at what happens with the numerator and denominator are quadratic expressions. For example, number 2 there, f of x equals x squared minus 4 over f over x squared minus x minus 6. So let's take a look at that function and graph that function. Same applies. We're going to find the horizontal, vertical, x-intercept if any, y-intercept if any, graph on point on the graph. Okay, I'm going to use a second paper here. And this is f of x equals x squared minus 4 all over x squared minus 6 minus x, minus 6. Okay, so first thing we're going to do is we're going to factor the top one. So I'm going to factor. That looks like a difference of squares, so I'm going to factor difference of squares. Then I'm going to factor the bottom one. X goes here. The middle term is minus 1. So what you have is a 3 and 2 for factors for 6. The outer and the inner. This is negative, so this is negative 3x plus 2x gives you negative x. Negative 3 times 2 gives you 6. And with this one here, I noticed there's a factor in there. So we're actually reducing our function here to x minus 3. So we're graphing this, and there's gonna be a hole at the x equals negative 2. So let's look at the graph here. I'm gonna move this up here, just about here. Okay. So I'm gonna draw your x-intercept and your y-intercept. Label all this first. So I'm gonna go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I'm just going to label the coordinate plane. This is 2, this is 4, negative 2, negative 4, 2, 4, negative 2, negative 4. X-axis, y-axis. So we start with the vertical asymptote, VA. That's x minus, denominator cannot be 0, so x is equal to 3. We draw the dotted line at x equals to 3. A vertical line. And we label it VA equals to x equals to 3. Now the easy one is the horizontal here, asymptote. If you recall, I'm going to do this. F of x equals x minus 2 over x minus 3. To find the horizontal asymptote, I'm going to multiply it by 1 over x to get rid of the x. I changed the form of the rational functions, not the function itself. Distributive property, 1 minus 2 over x over 1 minus 3 over x. And I look at the end behavior. X approaches infinity. This approaches 0. This approaches 0. And so f of x approaches 1. As x approaches negative infinity, f of x approaches 1 again. So I'm going to place a horizontal asymptote at here. So this should be 1 actually. Place it here. So y equals 1, and that's going to be your HA. Horizontal asymptote. Okay, so now we got the horizontal, y equals 1. Let's look at the x-intercept. The x-intercept is when, I'll put x-intercept here, is when the numerator is equal to 0, so x equals to 2. And I'll put 2 right here. The x-intercept is 2 right here. Okay, let's look at the y-intercept. I'm going to put the y-intercept here. And what happens to the y-intercept when x is equal to 0? So f of 0 equals to, put them in the original, negative 4 over negative 6, and it's 2/3. So So somewhere here, notice that, so this is gonna be, I'll place it up here, 0,2/3. So you know that your graph has to pass through the points. So I'm gonna draw the graph this way. And it never reaches the asymptotes and just approaches. So I'm gonna draw an arrow here, arrow here. The next one, I'm gonna pick 4. F of 4 equals to the right of the vertical asymptote. So I'm gonna pick 4 squared minus 4, and I'm gonna use this one right here. So this one right here. Actually, I'd rather use this one right here. 4 plus 2, 4 minus 2, 4 minus 3, 4 plus 2. Okay. This one's gonna cancel, and this one is, excuse me, this is gonna be 2/1. Okay, so actually it's right there, 2/1, 2,1. Okay, and you're gonna graph it up, always approaches the asymptote. Now comes the part we need to, x cannot be equal to 2. Okay, so if you equal to, cannot be equal to -2, excuse me. If you equal to -2, that original equation there, x equals -2, it's undefined because the denominator is gonna be 0. So at -2 here, somewhere here, you're gonna draw a hole there. So there's gonna be a hole at x equals -2. So to find that, -2 equals to -2 minus 2, -2 minus 3, -5 over -4, excuse me, over -5, 4/5. So this is undefined at that hole. So undefined at, I'm gonna place it as a point, -2, 4/5. Okay, and that's the second part to the graph right there.